All right, everybody, welcome to Earth Science. Today, we're going to tackle gradients, which is one of the equations you have here on the reference tables. We'll look at it, and you're going to be doing it on these topographic maps, which again, we're figuring out are like representations of Earth's surface. And I talked about this in the intro video, which you should have watched, thinking about how mathematically how steep a hill is. Remember I showed the one with my son's face that he hurt his face on my road, and then the ski slope. And I figured out how steep those hills are mathematically. And I said that was you were going to have to do it, and here we are. You got to do it. So here's the idea. Let me flip this over, do some quick jotting. You've done this before, whether you know it or not, because in math class, you've done this thing where you have a triangle like this, and you have to figure out the slope of this line, how steep it is. And the answer is to do rise over run, if you've ever heard that. How much do you go uphill divided by how much do you go distance-wise? Change in y over change in x. Those things all mean the same thing, and it means the same thing here. In earth science, we call it gradients. Change in field value divided by distance. Change in field value always confuses people. It's just what are the changes in the values on this map. The values on this map represent elevation, and there's numbers on there, 100, 50, and so on, and we can figure that out, and there's a contour interval. So what are the values? What are the elevations divided by distance, divided by how far apart they are? So in other words, when I did that thing with Silas riding his tricycle down the hill, that's a tricycle right there, we said, how much is he going downhill compared to how much is he going distance-wise, like as a ratio? I mean, if he went downhill 10 feet over a distance of a tenth of a mile, that's one thing. If he went downhill 10 feet over a distance of 4 miles, it's another thing altogether. That'd be a very gentle slope, right? So we're going to mathematically calculate those. How much do we go up and down divided by how much do we go distance-wise? That's the whole trick here. Now, if it takes watching this video a couple times, that's fine. We'll do that. But let's get it down. So let's start over here. Change in field value. How much do the values change? This one wants us to calculate a gradient. I believe. Oh, I put the line in the wrong spot. That line should be right there. Calculate the gradient along the reference line from A to B. Include units in your answer, which is going to be another thing we're going to start cracking on. So the value here at A is 50, and at B is 100. So how much did the values change from 50 to 100? And we're going to write that over here. If you go from 50 up to 100, you change by 50, and our contour interval is in meters here. So we went by 50 meters. All right. Distance. How much do we go distance-wise? Well, that's going to be using the scale right here. Now, different people do this different ways. What some people will do, I really advise using these pieces of paper here. I'll have a whole bunch of them for you. What some people do is stick that there and like make another scale on this piece of paper. That'll work. If that's your thing, go for it. What I've always done is to hold it here. It's going to be slightly tricky with a camera in the hand. And make a little mark. Accuracy is really going to be key as we do these, especially when you start the next thing, profiles. So I got a little mark on A. I'm trying to do this with one hand. Little mark on A. Little mark on B. There we go. Then I come down here, and my little marks are 4 kilometers apart. So that's it. That's pretty much my answer right there. 4 km. All you got to do is grab a calculator and divide 50 into 4 pieces, which, doing math in my head right now, hopefully it's right, comes out to 12.5. And then label, just steal what you already wrote. And I really advise that people write this down. I know that, like, do I have to show my work is always the question. And I know sometimes I say yes, and sometimes I say, don't worry about it. This is one where I'm not going to say you have to show it, but I will say that if you do show it, this right here answers the label for you. You don't even have to think. Just put down exactly what that was. 12.5 meters per kilometer. All right, so If you got it down, if you practice this one, I'm going to come around and check them as you go. This one has you calculate the gradient from C to D. These points right over here. So from C to D, do exactly that. How much do we go uphill, downhill? How much do we go distance-wise? You got a scale right there. You got a contour interval right there. You can do a little bit of work right there. You can do this. And it's not going to be the last one we do. We're going to do these over and over and over again. So that's why we're taking it nice and slow today. Make sure you do that. If you can do that one on your own, we're on the right path. Then we'll do a bunch more and combine some other things, and you'll do great. Thanks. Good luck.